Good morning. Today's the last lesson for this year. Just a quick reminder, I know I don't have very many seniors in this class, but if you are a senior, just a reminder that you do not need to do this lesson or activity. Your grades can be based off of the first 3 weeks only. So today we're going to be talking about the volume of pyramids and cones. We'll talk about where that volume formula comes from, and then we'll just do a few examples, and your worksheet, your homework is going to be a worksheet about a few examples of these. So the first thing I want you to do is to make a conjecture here. You've got two figures. We've got a prism that's got looks like a pentagon for a base, and we've got a pyramid. Remember, a pyramid is just one base and then triangles up to a point like that. So a pyramid that has the exact same pentagon for the base, the exact same height measured perpendicular to the base, and I want you to make a conjecture about what you think the relationship is between these two volumes. So basically, how much bigger is this prism than this pyramid? So make a guess there. And then let's go ahead and take a look and see if we can actually figure this out. So we've got a little video here, and just take a look. So he's filling up one pyramid, two pyramids, and we got the third pyramid. Is going to fill it up exactly. It looks like it's an exact fit. So what that tells us is it looks like it took exactly 3 of these pyramids to fill up a prism. We can keep watching this. Do you think it's going to be the same for triangular prisms and triangular pyramids? Let's skip ahead here. I have a feeling you can guess. There's 1, there's 2, and the third one. So 3 times for triangular pyramids and prisms. And then the one that might be a little different here. What about for cylinders and cones? Same base again. Same height. And we're going to fill it up once. Twice. And it looks like 3 times fills it up exactly. So let's go ahead and pause that. So it looks like for pyramids, we basically have 1/3 of the corresponding volume of a prism. So if the bases were the same, the heights were the same, it'd be 1/3 the volume. So what that tells us here is that the volume of a cone or a pyramid is just going to be 1/3 what it is for a prism. And so for a prism, we just take the area of the base times the height. And for a pyramid, which you just saw that it fits in 3 times to that prism, we're just going to take it by 1/3. Or you'll also see it written this way: the volume of the area of the base times the height divided by 3. Whichever way makes the most sense for you in a particular case. Doesn't really matter. And remember, this is the area of the base. That's why it's written as a capital B times the height. So let's go ahead and take a look at some examples here. Our first one, we've got the area, or not the area, the volume, get that right, of this triangular pyramid. And so our triangular pyramid means we've got a triangle as the base. And you can see right there, the triangle pen, we've got a triangle as a base. And we're going to find, first of all, the area of that base. And since it's a triangle, we've got 1/2 times the base of the triangle times the height of the triangle, which is 8 and 14. So area equals 1/2 times 8 times 14. And ask your calculator what that is, but that's going to be 56 units squared. That's the area of the base. Next up, we just have to put that into our volume formula. And so our volume formula for a pyramid is just going to be 1/3 the area of the base times the height. So now we're into the volume formula, 1/3 times the area of the base times the height. Now this height is the height of the pyramid. That's the 17 here. Don't get that mixed up with the height of the base. So we have our volume. Volume equals 1/3. The area of the base was 56. The height is 17. And we'll plug that into our calculator. 56 times 17. And then just divide by 3 or multiply by 1/3. And I get 317.3. We're just going to round to the nearest tenth is fine. And since we're talking about volume, that's cubic units. Okay, next up, let's take a look at this, this cone. And so we'll talk about two different ways we could do this, either leaving it in terms of pi or giving a decimal answer. But it's going to start off the exact same way. We're going to start off with finding the area of the base. And this time it's a circle. So we've got pi r squared for the area of the base with a radius of 3. So pi times 9, or we usually write that as 9 pi. And that's square millimeters, because we're talking about area right now. Then we can take that and find the volume equals the area of the base times the height divided by 3. And so our area of our base is 9 pi. Our height is 7, and we can divide by 3. Now, if we want to leave this in terms of pi, one of the things we can do is just start to simplify a little bit our fraction. A 9 and a 3 both have a factor of 3 in it, so I can take that out. If there's just a 1 on the bottom, on the top I've got 3 times 7 is 21 pi. If we want to leave that as a decimal, we can just type it in our calculator. 9 times pi times 7, and then divided by 3. And it turns out that that's approximately 66.0 millimeters cubed. This would also be millimeters cubed. So those ones are pretty straightforward. Find the area of the base. On your homework, it's just to the nearest tenth, so you don't need to worry about any of the pi stuff, just to the nearest tenth. And then multiply by the height and divide by 3. So one extra thing we can do here with these is something like this, working backwards. We've got a volume of 24 pi, and they tell us the radius of the base, but they don't tell us the height of the base. That's what we're trying to solve for here. So if we think about our volume formula being the area of the base times the height divided by 3, I know the volume. I have enough information to find the base, and the height's what I'm trying to find. So we'll start off by finding the area of the base. It's actually the same as the one we just did. So pi r squared equals pi times 3 squared is 9 pi. And so now I'm just going to plug in what I know. The volume is 24 pi. You'll notice that the pi is in there, so I'm leaving it. The area of the base is 9 pi. We don't know the height, and we divide by 3. So now we got a couple options here. We can just start undoing operations, or we could actually take a step here and simplify. That would be helpful. The 9 divided by 3 is just 3. So 24 pi equals 3 pi times h. And then my last step here, I can divide by my 3 pi on both sides. On this side, that'll just cancel out. 3's cancel, pi's cancel. On this side, the pi's cancel. And 24 divided by 3 is 8, which is going to be our height. And I believe they said that's in inches. Okay, so that's going to cover what you've got on your homework. It's going to be a worksheet. It's actually a mixed worksheet of prisms and pyramids, also cylinders and cones. So just remember, when you've got something like this, which is a cone, or something like this, which is a pyramid, your volume formula is this one right here. Either 1/3 base times height, or base times height divided by 3. They're the exact same thing, whichever one's more useful. If you've got something more like this, which is what we had for last week's homework, then our volume is going to be the area of the base times the height, and that is it. But one more assignment here. Get that turned in. It's due the 26th, which is next Tuesday. This one's a pretty big one. If I don't have them by the 26th, we're getting into the time where I'm not going to be able to get your grades updated in time for the end of the trimester. So get those in on the 26th. That's going to give you a chance to get those graded, and if you have to fix anything, for me to get those back to you. Other than that, remember, we still have office hours this Tuesday and this Thursday, and I'll also hold office hours next Tuesday and next Thursday. Those ones next Tuesday and next Thursday are going to be if you need to make some corrections to any of these things. You should already have all the homework done by then. But other than that, this is the last time you'll probably hear from me this year. So have a great summer, and hopefully I'll see you all next year.